Hopefully you'll have a better feel of differential equations after this tutorial. You'll have learned that the motivation for differential equation is looking at what they see and describing it as change. You'll have gained an intuitive relationship between the solution and the form of the differential equation. So the relationship between the change in membrane potential and membrane potential, for example. How the different parameters of the equation impact the solution, and how there are strengths and limitations of these simple differential equations. In the next tutorial on numerical methods, we'll learn about different ways of estimating solution of more complicated differential equations, which don't have exact solutions yet. But your intuitive feel of differential equations will help you with understanding more complicated differential equations. Seeing, oh, that's the input to the equation, see how that affects the output. These kind of simple experimental approaches to differential equations, I think, are vital to get an intuitive feel of them. You'll see differential equations across Neuromatch. They'll turn up on different days. The Leak Integrate and Fire model turns up on the model types week 1, day 1, and real neurons, week 2, day 2. The drift diffusion model, which is a differential equation for describing decision making, is discussed in the linear systems in week 2, day 3. Systems with differential equations are discussed in linear systems in week 2, day 3. And dynamic networks in week 2, day 4. If you really want to read more about this, here are some little references. The Lockta paper is about the population equation. The Brunel von Rossen paper is just a more modern version of the Peak paper from 1907. Some textbooks that are very good is the Dahan and Abbott Theoretical Neuroscience textbook. But also about differential equations is the Stephen Strogatz book. It's very readable. I know it's a maths book, but it's actually a very well written maths book. But maybe if you don't want to read the textbook about this and get a more intuitive feel, Lindsay Grace, who worked in Neuromatch Academy last year, has written a fabulous book called Models of Mind, How Physics, Engineering and Mathematics Has Shaped Our Understanding of the Brain. It's well worth the read. Stephen Strogatz' book Sync, The Emerging Science of Spontaneous Order, has a good lot of neuroscience in it, which describes syncing of systems, which is described by differential equations. And lastly, Stephen Strogatz has a really fascinating podcast where he talks to mathematicians, neuroscientists, and many other people about how mathematics and their science are related.